Nextron's TraceMate electronic thermostat is designed specifically for control of electrical heat trace. It is a single-circuit controller rated for up to 30 amps, 277 volts. The unit has ground fault trip capability and comprehensive alarm package. This video will provide an overview and cover basic setup, operation, and troubleshooting. Prior to installing the controller, please ensure that the ratings on the white nameplate found on the outside of the thermostat enclosure are suitable for your application and power feed. TraceMate units come in three different models: 120-volt single pole, 208-240-volt dual pole, and finally, 277-volt single pole. Applying incorrect voltage will likely result in damage to the unit. Once the installation is complete, power the unit up. You should see the green Power On LED lit inside the controller. Other LEDs are indicative of the current status of the following: HTR on. The heater is on and drawing current. RTD fail. Problem with the RTD measurement. Low temp. Low temperature alarm is present. High temp. High temperature alarm is present. Amp fail. Low current alarm is present. GF. Ground fault trip. Each LED's status, with the exception of power and RTD, is dependent on programmed parameters. You can find default programmed values on the yellow sticker found on the inside of the controller door. If you change the default set points, write the new values into the blanks provided for future reference. When lit, the large green LED on the front of the controller door indicates the power to the controller is on and no alarms are present. It is not indicative of the heater on or off status. If the green LED is off, one of the following is occurring. 1. The thermostat is not powered up. Or 2. There is an alarm present. Once these conditions are rectified, the green LED will light up again. To program the TraceMate, you will need to use a combination of Dipswitch and jumper positions. Select the parameter that you want to program by placing the jumper in its respective position. They are as follows: SP, heater set point; AMP, low current alarm; GF, ground fault current; HT, high temperature alarm; LT, low temperature alarm. Once the jumper is in the correct position, move the dip switch over to the right to program the value you want. The first 9 switches have incremental values from 1 to 256 on the right side. As switches are moved to the right, they add up to give you a programmed value. Switch number 10 enables you to operate in Celsius when the switch is over to the left, or Fahrenheit when the switch is over to the right. Switch 11 is used to clear any latched alarms, and switch 12 is for test forcing the heater on regardless of the set point and temperature input. Heater set point programming. Heater set point determines the temperature the thermostat will maintain. This is the only setting that controls when the heater will turn on and off. In this example, we will program the thermostat to maintain 45 Celsius. First, ensure that you have the desired temperature scale selected, in our case degrees Celsius, and the switch is over to the left. Place the jumper in the SP position. Place switches with the following values over to the right: 32, 8, 4, and 1 to add up to 45. Once set, place the jumper back into none position and push the dip switches over to the left. Low temperature alarm programming. The low temperature alarm setting determines the temperature level at which the thermostat will begin generating a low temperature alarm. This setting does not control the heater in any way, only the alarm threshold. In this example, we will program the low temp alarm at 5 Celsius and below. Place the jumper in the LT position. Place switches with the following values over to the right: 4 and 1 to total 5. Place the jumper back into none position and push the dip switches over to the left. Low temperature alarm disable. The low temperature alarm can be disabled entirely. This can be useful in applications where the RTD is measuring ambient temperature. To do that, place the jumper in the LT position. Then place the first 9 switches over to the right. This will disable the LT alarm. Place the jumper back into none position and push the dip switches back over to the left. High temperature alarm programming. The high temperature alarm setting determines the temperature level at which the thermostat will begin generating a high temperature alarm. This setting does not control the heater in any way, only the alarm threshold. In this example, we will program the high temp alarm at 64 Celsius and above. Place the jumper in the HT position. Then place the switch with the value of 64 over to the right. Once set, place the jumper back into none position and push the dip switch over to the left. Low current alarm programming. The low current alarm setting determines the amperage level below which the TraceMate will generate a low current alarm. Please note that for the low current alarm to be active, two conditions must be met. 1. The heater must be on and calling for heat, and 2. The current drawn is below the level that is established by this setting. In this example, we will program the low current alarm to be turned off. Place the jumper in the amp position. Then ensure the first 9 switches are over to the left. This combination gives us a total of 0 amps and effectively turns the low current alarm off. Place the jumper back into none position, and please note the total value of dip switch positions from number 1 to number 9 is divided by 10 to arrive at the low current alarm value. For example, if you had selected switches 1 and 2, the total of 3 is divided by 10 to arrive at the setting of 0.3 amps. Clearing latching alarms. Please note that the low current alarm and the ground fault trip are both latching type alarms. This means that even if the condition that generated the alarm is gone, the alarm will not clear itself and remain in place until the reset dip switch, number 11, has been toggled as shown here. If after clearing, the latching alarm comes right back, this means that the condition is still present and needs to be addressed, or your alarm levels need to be adjusted to a more suitable value. Ground fault trip programming. The ground fault trip setting determines the ground fault milliamp level above which the TraceMate will trip and interrupt the flow of current to the heater. Until cleared, the heat trace will not draw any current due to the potential of a ground fault hazard. The scale of this parameter is measured in milliamps. In this example, we will program the ground fault trip to be 25 milliamps. Place the jumper in the GF position. Then place switches with the following values over to the right: 16, 8, and 1. When you add these numbers together, the total is 25, our desired ground fault trip threshold. Place the jumper back into none position and push the dip switches over to the left. This concludes our TraceMate overview video. Please refer to the manual for more details or call us toll-free.